Hi, welcome back to Science 1206, the Chemical Reactions Unit. I'm Ms. Ledwell, and this video is a continuation of our discussion on an introduction to chemical reactions. Let's begin. A chemical reaction is defined as a process by which one or more substances transform into new substances with distinct chemical and physical properties. A chemical change takes place. Some examples of chemical reactions include iron reacts with oxygen in the presence of moisture to form iron oxide or rust. In the presence of sunlight, plants photosynthesize, converting carbon dioxide and water into glucose and oxygen. And burning wood in the presence of oxygen produces carbon dioxide, water, and ash. The elements or compounds that undergo a chemical reaction are called reactants. The substances formed in a chemical reaction are called products. A chemical equation tells the story of a chemical reaction. You can see the reactants on one side of the arrow, and we have two hydrogen and we have oxygen gas. And then our products are on the other side of the arrow. Our product in this case is water, two water. Chemical equations are a way to represent chemical reactions using chemical formulas and symbols. In chemical equations, the reactants are written to the left of an arrow and the products to the right. The arrow means yields or produces. If there is more than one reactant or product, they are separated by plus signs. So the plus sign means react with, and the arrow means yields or produces. Word equations are another way to represent chemical reactions. In word equations, the names, not the symbols, of the reactants are written to the left of an arrow and the names of the products to the right. The arrow is still used to indicate yields or produces, and if there are multiple reactants or products, they are separated by plus signs. Here's an example of a word equation. We have chlorine plus sodium. These are our reactants on the left of the arrow, and our product is sodium chloride on the right of the arrow. Here's another example. We have potassium carbonate is our reactant on the left of the arrow, and our products, potassium oxide and carbon dioxide, are on the right of the arrow. In chemical equations, the physical state of a substance is often indicated right after its formula. It may be a solid, indicated by a lowercase s in brackets, a liquid, indicated by a lowercase l in brackets, or a gas, indicated by a lowercase g in brackets. We can also have aqueous solutions, and these are indicated by an AQ in brackets. Here are some examples. So we have H2O, and it's in the liquid state, so in brackets we have a lowercase l. Next we have sugar, C12H22O11, and it's in the solid state, so there's a lowercase s in brackets. And our next example is propane, C3H8, which is a gas indicated by the lowercase g in brackets. An aqueous solution, represented by AQ in brackets, means that the substance is dissolved in water. During chemical reactions, atoms are neither created nor destroyed. They're simply rearranged. In other words, all the atoms on the reactant side of the reaction exist on the product side of the reaction, but in a rearranged form. For example, in the equation chlorine plus sodium produces sodium chloride, we have our reactants, chlorine and sodium, and our product, sodium chloride. All the atoms on the reactant side, chlorine and sodium, are also present on the product side, but they're just rearranged into sodium chloride. Also in a chemical reaction, the total mass of the products is always equal to the total mass of the reactants. This is called the law of conservation of mass. For example, if we have 70 grams of chlorine and 40 grams of sodium, our product, sodium chloride, should be the sum of those two, 70 plus 40, which is 110 grams. So again, the mass of the product always equals the mass of the reactants. Let's do some practice naming the reactants and products in equations. Our first example is a description of a chemical reaction. Aluminum bromide and chlorine gas react to form aluminum chloride and bromine gas. What are the reactants here? The reactants are aluminum bromide and chlorine gas. So it says they react. To form means the products. So the products are aluminum chloride and bromine gas. Our next example is a word equation. We have lithium fluoride plus chlorine gives us lithium chloride plus fluorine. So in this case, we know that our reactants are on the left side of the arrow. Our reactants are lithium fluoride and chlorine. Our products are on the right side of the arrow. Our products are lithium chloride and fluorine. Number 3, also a word equation. We have iron plus oxygen produces iron 3 oxide. So in this case, our reactants are on the left of the arrow, iron and oxygen, and our products are on the right, iron 3 oxide. Our next word equation is methane plus oxygen produces carbon dioxide plus water. Our reactants are on the left of the arrow, methane and oxygen, and our products are on the right, carbon dioxide and water. And our last example is the word equation aluminum plus copper 2 chloride produces aluminum chloride and copper. Reactants on the left of the arrow are aluminum and copper 2 chloride, and our products on the right are aluminum chloride and copper. Now it's time to review. Complete the learning activities found in Brightspace.